Okay guys, let's discuss the JEE main pattern exercises for the chapter integrals. First question says integration of fx, which is given to be as under root 1 plus x square with respect to not x, but this time x square will be what? So question is basically asking you to integrate under root 1 plus x square, but with respect to x square itself. Now if you can understand, because 1 is a constant, therefore this can be written as or rewritten as d of 1 plus x square. Right? D of x square is same as d of 1 plus x square, 1 is mere constant. Now what I do is, if I take 1 plus x square as t, if I take 1 plus x square as t, I get integral root t dt, which is something very easy, you know. This is nothing but equal to 2 by 3 t to the power 3 by 2. But that's not the answer because t is being taken as 1 plus x square. So your answer is 2 by 3 1 plus x square to the power 3 by 2, and that is what is the indefinite integral of under root 1 plus x square with respect to x square. So 2 by 3 1 plus x square to the power 3 by 2 plus obviously the constant of integration, and therefore B is the correct answer. The next question says what? It says that if integral e to the power ax cos bx dx is given to be this, then f double dash x will be equal to what? So you are given the information of a certain expression. On the basis of that, you are being asked to compute f double dash x. Now if you can recall from this expression, this is something we have already witnessed and we know the general scenario which follows for this particular expression. Why? We know that integral e to the power ax cos bx dx is actually equal to, it is given in the question as something else, but it is actually equal to e to the power ax upon a square plus b square, a cos bx plus b sin bx, right? But this has been given equal to e to the power 2x by 29 fx plus constant of integration. Obviously plus c is going to come in both the places. So if you compare both these expressions, what you get is a is 2, clearly a is 2. Also you get that a square plus b square is 29. If a square plus b square is 29, I get 2 square plus b square is 29. So b square is 29 minus 4, that is 25, so b is 5. A is 2, b is 5. Also if you compare, you get fx is a cos bx plus b sin bx. Now if fx is a cos bx plus b sin bx, then what is f dash x? It is minus a b sin bx. Why? Because a constant, d by dx of cos bx is minus sin bx into b. So minus sin bx into b plus here it will be b square cos bx, right? Again if you differentiate, you get what? Minus ab is already here, square cos bx, and here it will be minus, this is what? B, this was cos bx, so b square, and then here you get b cube sin bx, isn't it? Because d by dx of cos bx is minus sin bx into b, b square is already over here. So from here if you take out minus b square common, you are left with a cos bx plus b sin bx, isn't it? Isn't it? This is minus a b square cos bx minus b cube sin bx, but a cos bx plus b sin bx is equal to fx. So f double dash x has come out to be equal to minus b square fx. But we know that b is equal to 5, so your answer is minus 5 square fx, that is minus 25 fx, and that is what is f double dash x. It has come out to be equal to minus 25 fx or minus b square fx, where b is 5. Clear? Easy enough question. Next we have, if integral fx dx is this, then fx will be what? Okay, so let's see how to tackle this question. Okay. So integral fx dx is given to us as what? Integral fx dx is given to us as twice of fx whole cube plus c. If you differentiate both sides with respect to x, because I want fx, so I don't want this integral sign, I want my fx to get rid of this integral sign. D by dx, when you do, you are just left with fx. This is 2 constant, 3 into fx whole square into f dash x. So over here you get 6 fx whole square into f dash x. Right? This is what you get by chain rule. After this, you can see fx over here, fx over here. 1 fx gets cancelled. You are left with 6 fx f dash x equals 1. From here, the very situation of obtaining fx starts. You can write this as this. This is d by dx of fx equals 1, which alternatively can be written as what? 6 fx d of fx equals dx, and now you can integrate both sides. Here with respect to fx and here with respect to x. When you do this, what is it that you get? You get 6. Integration of x dx is x square by 2. So here you get fx square by 2. And this is equal to x. You are left with fx whole square is x by 3. So fx you are having as under root x by 3. That is how you compute your fx when you have the information that integral fx dx is twice of fx whole cube. Now if I move towards the next question, let's see what that calls for. Question is, if this is equal to a log x plus 1 plus b log x minus 2, then what is the relationship between a and b? Now you can see over here, integration by partial fractions is going to come into picture. It is very, very simple. Integral of 1 upon x plus 1 into x minus 2. This will be what? If you put x equals minus 1, I have taught you already in my lectures how to get the values. If you put x equals minus 1, you get 1 upon minus 3. Just ignore this expression, put x equals minus 1. You get 1 upon minus 3 or minus 1 upon 3 times 1 upon x plus 1. That's what you get. Plus, if you put x equals 2, not in this expression, in the rest of the expression, x equals 2 gives you 1 upon 3. So you get 1 upon 3 times 1 upon x minus 2, and you need to integrate this now. Now it's very, very easy. This gives you minus 1 by 3 log of x plus 1 plus 1 by 3 log of x minus 2. And this is exactly equal to the expression a log x plus 1 plus b log x minus 2, and therefore you get that a is minus 1 by 3, b is 1 by 3, so a plus b clearly is coming out to be 1 by 3 plus minus 1 by 3, which is 0. Easy enough question, just using the very partial fraction scenario of integration. If integral fx dx is fx, then what is integral fx square dx? Let's see how to tackle this question. Integral fx dx is fx. If integral fx dx is fx, it clearly means d by dx of fx is fx. d by dx of fx is fx means I can write this as 1 by fx d of fx equals dx. Right? And now I can integrate both sides. This gives me log of fx equals x plus some constant of integration. Log already I have. I'm going to just take for convenience log c as the constant of integration. Now I can write this as fx equals e to the power x plus log c, which is e to the power x into e to the power log c, which is e to the power x into c. Fx is c into e to the power x, so fx whole square will be c square e to the power x whole square, which is this. And when you integrate fx whole square, you actually integrate this, which comes out to be what? C square is constant, integration of e to the power 2x is this upon 2, right? And your answer comes out to be 1 by 2 c square into e to the power 2x, which actually is this. Fx whole square is this, fx whole square c square into e to the power 2x into 1 by 2 is what is the integration, right? So integration of fx whole square dx is what? 1 by 2 fx whole square, right? Just this 1 by 2 is going to come out, rest fx whole square remains the same. Clear? Moving to the next question, we have what is the absolute value of this given integral expression? Okay, so talking about this, you need to first focus upon the values which x can basically acquire in this expression. For this question, I am given that x is going to range from 10 to 19. So x is already given to be greater than equal to 10 and less than equal to 19. Greater than equal to 10 means what? X to the power 8 will be greater than equal to 10 to the power 8. Obviously, if I add 1 to it, again the inequality holds. So this is something that you already have. Now over here you need to find the absolute value of this expression, means you need to find this. What is this? You know that mod of the integral is less than equal to integral of the mod of cos x upon mod of 1 plus x to the power 8. But 1 plus x to the power 8 is already positive, so there is no need to put this mod sign. So this dx. Now if 1 plus x to the power 8 is greater than equal to 10 to the power 8, this implies 1 upon 1 plus x to the power 8 is less than equal to 1 upon 10 to the power 8, which is 10 to the power minus 8. So over here you know that mod of cos x is always less than equal to 1, right? For any x which is coming from any real number, mod of cos x is always less than equal to 1. So this is less than equal to 1, and 1 upon 1 plus x to the power 8 is less than equal to 10 to the power minus 8. So 1 into 10 to the power minus 8, which is this. So obviously this comes out to be equal to what? This comes out to be equal to what? 10 to the power minus 8 into x, where x is ranging from 10 to 19. So that is going to give you 19 minus 10. This is 9 into 10 to the power minus 8, which is clearly less than 10 to the power minus 7. If it is clearly less than 10 to the power minus 7, option number A is the correct one. The only thing to be used over here is the very simple concept that mod of the integral is less than equal to integral of the mod, and that mod of cos x is always less than equal to 1 no matter what real number x is acquiring. Next question says, if fx is a periodic function with period t, then which among the following is the correct statement? Now over here, if you remember the theory part that we've done, directly you will be able to see the answer. Which one is it? It is option number C, isn't it? Why? Because we know that integral a plus nt to b plus nt fx dx is equal to integral a to b fx dx, and this is true for all integers. Over here specifically for n equals 1, the expression is given to you. A plus 1t, b plus 1t. See, a plus 1t, b plus 1t, fx dx is a to b fx dx. So this is obviously right. If you have just the knowledge of basic, very basic properties which functions which are periodic with period t acquire, very directly you will be able to get the answer. Fine. The next question says what? Let fx be equal to this, then the roots of this equation are what? Real roots. Okay. Let's see. So fx is this, that means what is f dash x? If fx is this, what is f dash x? It is under root 2 minus x square and not t square. If f dash x we know, I am interested in this equation, x square minus f dash x equals 0. X square minus, this is f dash x, equals 0. X square equals 2 minus x square with under root. Squaring both sides, I get x to the power 4 equals 2 minus x square, which is x to the power 4 plus x square minus 2 equals 0. You can write this as t square plus t minus 2 equals 0, where t is x square. Now this is a quadratic equation. T will be equal to minus b plus minus root over b square minus 4ac upon 2a. So this gives you minus 1 plus minus 3 by 2, which eventually gives you 1 and minus 2 as the answer. Right? T is 1 and t is minus 2. T is x square. X square is always non-negative. It can never ever acquire a negative value. So that means t cannot be equal to minus 2. Therefore, t is equal to 1. That means x square is 1. So x is plus minus 1. So the roots of x square minus f dash x are x equals plus and minus 1. Fine. Next question. Let fx be a polynomial of degree 2. Okay. So the expression is not given to us, a generalized description is given to us about fx, that it can be any polynomial. It is a polynomial of degree 2 which satisfies f of 0 is 1, f dash 0 is minus 2 and f double dash 0 is 6. Right? So we are going to generally consider any polynomial of degree 2 as ax square plus bx plus c. F of 0 it is saying is 1. F of 0, 0, 0 plus c, so c is 1. F dash 0 it is saying is minus 2. What is f dash x? F dash x is 2ax plus b. So f dash 0 will be b, so b is minus 2. F double dash 0 it is saying is 6. What is f double dash x? It is 2a. F double dash 0 is 6, that means 2a is 6, which implies a is 3. So you have fx very easily coming out to be 3x square plus 2x plus 1, because a is 3, b is minus 2 and c is 1. Now the question is to integrate fx from minus 1 to 2. The moment you have fx, it is a simple polynomial. You can very easily integrate it. Integration from minus 1 to 2, 3x square minus 2x plus 1 dx. This will be equal to x cube by 3, 3 cancels from minus 1 to 2, or let me just evaluate it right at the end. This minus, this is x square by 2, 2 cancels plus x from minus 1 to 2. This gives you 8 minus 4 plus 2 minus minus 1 minus 1 minus 1, which gives you 9 as the answer. So your integral is coming out to be equal to 9. That's how beautifully this question has first indirectly asked us to compute the very function also fx. It has not given us the function. Once the function is computed, then calculate the integral. After this, we have this question very clearly based upon the L'Hopital rule. This is very, very important. Leibniz rule we have done. Based upon it, we have to tackle with this question. Why? Because right now it is of the 0 by 0 form. So I will be interested in applying the L'Hopital rule, but in the numerator, I will have to actually apply the Leibniz rule, right? So when I do that, what I get is 2 is already here. Limit x tends to 0. How is it applied? This becomes cos inverse of cos x into d by dx of cos x, which is minus sin x, minus cos inverse of 0 into d by dx of 0, which is 0. So there is no expression in here now. That's it. Whole upon, differentiate this. This is 2 minus, what is d by dx of sin 2x? It is 2 cos 2x. Fine. Now you can see from the numerator and denominator 2 can be cancelled, because I can write this as 2 common 1 minus cos 2x. This 2 gets cancelled out. What you get over here is x into minus sin x, because cos inverse of cos x is x. So minus x sin x upon 1 minus cos 2x is 2 sin square x. Limit x tends to 0. You can very clearly see now you are left with limit x tends to 0. Limit x tends to 0 minus x upon 2 sin x. Right? This is minus 1 by 2 outside, it's constant. Limit x tends to 0, x upon sin x. Now you know that as x approaches 0, sin x approaches x. The graph of sin x becomes just exactly equal to, almost equal to the graph of y equals x when x is approaching to 0, when it is very, very close to 0. So this eventually comes out to be equal to 1. Right? If this comes out to be equal to 1, your answer is minus 1 by 2. That is what is the limit. And that brings me to the end of the discussion of these questions. That's it from my side. Thank you.